Assalamu alaikum. Today I am going to the first lecture of Discrete Homotopy Theory to compute the fundamental groupoid or fundamental group in Discrete Homotopy Theory. Okay. So we will discuss 5 sections in this lecture series. First section, preliminaries, and in second section, we will discuss about the finite formulation of the homotopy graphs. In third section, this is very important thing, the fundamental groupoid. And fourth section, also important, covering graphs. And fifth section, which is very much important to compute to determine the fundamental groupoid or fundamental group in graphs, Seifert-Van Kampen theorem for graphs. Okay, so let's start the first section, preliminaries. In first section, we will discuss about first graphs. Okay, so what is graph? So precise definition of graph. So graph is the ordered pair of two sets, which is the set of vertices and the second set of edges. Okay, graph is a structure of ordered pair of two sets. First set is the set of vertices and second set is set of edges. Okay. So what is edge? So edge set is equal to or subset, we can say subset of V cross V, where V is the subset of where V is the set of vertices of graphs. So edge is the subset of V cross V, the Cartesian product of vertices set. So what type of the element of edge? So x comma y, where such that x and y belongs to V. Okay, set of vertices means this type of objects, this type of elements, this type of entries belongs to these sets. And what type of meaning? Means x comma y, where x comma y means, what is the meaning of x comma y? X comma y is the edge. X comma y means the edge between x and y, denoted by tilde, or we can denote x comma y in ordered pair, means the x and y are related to with an edge. So secondly, we define graph maps. So second, I am discussing about the graph map. A graph map. What is the definition? A graph map. A graph map f from x to y, where x comma y are graphs, is a function. Is a function. So what type of function? Is a function f from xv, the set of vertices of graph x, to the set of vertices of graph y on the underlying set, vertex set function on the underlying vertex set satisfying the following properties. Satisfying the following properties. What type of properties or axioms as well? So if x comma x dash is an edge in x graph, so then f of x, the image of x and image of x dash, or edge in y, belongs to the vertex edge set of y, or f of x is equal to f of x dash, means both are if x and x dash are adjacent, or we can say the edge between x and x dash. So the two properties, two conditions hold. First, either the edge between fx and fx dash or both are equal, means both the images are equal. Okay, so this is the definition of graph map. Means if the edge in x, if the edge if the edge lie in x graph, so the image under the graph map, so the image under the graph map f of x and fx dash are adjacent or equal. F of x is equal to fx dash. There is a one condition satisfied, so we can say the f is the graph map from first graph x to graph y. Okay, so this is given, that is given an edge in the domain graph x, if either the graph map either contract it to a single vertex, contracts to a single vertex, single vertex in codomain y, in codomain y, or or map maps to an edge in a codomain graph y, and the domain domain graph y. Okay, means there are two possibilities on f. First, f sent edge from x to y to a single vertex, means f of x is equal to f of y, or sent to edge f of x to f of y. Okay, there are two possibilities. One possibility is hold if there is a graph, there is a graph map f. So some examples of graphs. So first of all, interval graph, interval in, where n belongs to the natural number. Okay, so what type of this graph? Vertices set are integers. What type of integers? From 0 to 1, 0, 1, 2, and so on. Positive real numbers from 0 to n. Okay, sorry, positive integers, non-negative integers, sorry. So vertices, what type of vertices of this graph? Non-negative integers from 0, 1, 2, 3, and so on to n. And what type of edge set? So edge set are, so I to I plus 1, where I is equal to 0, 1, 2, and so on to n minus 1. Okay. For example, if we have a graph I0, so there is one vertex 0 and no edge between them. If we choose I1, so there are two vertices according to the vertex set 0, 1, and there is an edge 0 to 1. Okay, 0, 1 according to this definition of edge. If we choose I3, so vertex, how many vertices? 0 to 1 to 2 to 3, okay. And edges, how can we we can write edge 0 to 1, 1 to 2, 2 to 3, okay. Three edges. There are three edges. We said this for from this formula we can write the edge set, okay. 0 to 1, this is the first edge, this is the second edge, and this is the third edge, okay. Now another graph I am defining I infinity, whose edge sets are whose vertices sets are integers, whole integers. I belongs to integers, okay. And edges, what type of edges there are? This type of edges set I to I plus 1, where I from 0, 1, 2, and so and n minus 1, okay. Sorry. In this graph, edges belongs to also integers. Edges belongs to also the integers. So how can we represent there is 0, there is 1, there is 2, there is 3, and so on. And there is minus 1, there is minus 2, and there is minus 3, and so on. Okay. These are the vertices 0, 1, 2, 3, and minus 1, minus 2, minus 3, and so on to till to minus infinity. And there are also to positive infinity. These are the I infinity graph. Okay. I infinity graph. What type of I infinity graph? Vertices are belongs to the integers, and set of edges. How can we write the set of edges? Set of edges, the ordered pair I to I plus 1 means if we talk about this edge, so how can we I is equal to 0 and then I plus 1 is equal to 1, and this edge is 1 to 2 and this edge is 2 to 3. And about if we talk about this edge, so minus 4 to minus 3, okay. So all the edges are like these, okay. Now I am going to end this video. Inshallah, in the next video I will define other topics related to preliminaries. Then we will go to second section. Okay, Allah Hafiz.